Hello everybody, my name is Patrick, and today I would like to give you some insights of my personal journey to a statically typed future. And just to get you started, I want to give you some context of who I am, and just to give you some relation. Maybe my personal way is not the perfect fit for you, so take everything I say with a grain of salt. It's a highly opinionated topic as well. So 2007 I started out as a Java developer, and as we all know, Java is like a statically typed language, although it's a very weird type system in my opinion. And at some point I reached this level in 2011 when Node.js came out, and I was like, oh, that's some really nifty technology right there. And I tried to build a product with it. And I really loved the fact that suddenly everything is dynamic and you could move much faster than with Java itself, because it's a very rigid structure when you build a code. And in Q4 of 2015, I suddenly had a nice opportunity to work on a mobile application, and we built a newsfeed feature for Runtastic, for their fitness app, which was built in React Native. So it was JavaScript on the mobile part, and this was also very interesting paradigm-wise, because suddenly we had this functional concepts, and I was really into this functional programming thing. I think we heard a lot about functional programming today as well. So it's something which is coming into a trend again, so that's nice. And after a while I realized that JavaScript itself, if you have a really big code base, gets really overwhelming. So it's getting really hard to refactor stuff. So very shortly after I used React, I started to invest some time into statically typed JavaScript. And I stumbled upon Flow, which was released in that time with version 0.15. And maybe you use Flow. So right now it has version 0.46. So there were 20 version releases in between. So this was almost 2 years ago, and I have been using it for quite some time, so more than 1.5 years. So I want to give you, like after this talk, I wanted to give you some insights why I believe that static type systems aren't as bad as everyone thinks they are. And maybe I motivate you later on to maybe try it yourself. And I mean, I'm one step ahead actually, because with Flow you have quite solid typing already. Maybe you have been attending to the previous talk before, which was in Russian. I'm not sure how many has seen that. But I would like to go one step further and say what I believe will be an even better typing experience in 2017. All right, so first of all, clear up the question for those who didn't attend the last talk. What is a type system? So usually when we hear something about a type system, we think about syntax. We think about, okay, we have our code and we have type definitions like our parameter, which is a number right here, and a return type of type string. And then we have a tool which reads our code, which parses it, makes an abstract syntax tree out of it. An abstract syntax tree, or AST, is just a very big data structure. So if you want, you could even plot it out as a JSON object, and the tool will analyze it. And the analysis engine of the type system is the most important part. And I would like to just let you know, because a lot of people are not aware of this, but not all types are equal. And let's make it a little bit more authentic, because at every tech conference you usually have this, check marks of lists and say which technology has which feature. So, for instance, we see type system. Okay, we have maybe types, so nullable types, like in Swift or in Flow and TypeScript. Sure. Both of these technologies have that. Oh, by the way, I'm not trying to compare Flow and TypeScript at all. I'm just saying, like, they are very similar technologies. They try to cover the same use cases. Each of them has their strengths. I don't want to say that TypeScript is worse. I'm obviously biased with Flow. But yeah, just let's go on. Okay, generics. Sure, yeah, we have that as well. These are the angle brackets like we know them from Java. Covariance with classes and whatsoever. Yeah, sure, we have the subtyping. Yeah, clearly we have that. And inference for types in local scope. So, like the first question, are like, I have been on many conferences talking about Flow, and the very first question every time was, so why should I use Flow instead of TypeScript? This is a very confusing question, because you have this checklist, you see all these features are there. Now it's just a matter of choosing one technology. And most of the people are choosing TypeScript for its tooling, because clearly the tooling, the editor support, the interoperability code is much, much better, in my opinion. Flow has a lot of stuff which doesn't integrate that well. But for me personally, the quality of the typing is much more important. As I said, the analysis part of a type system is the most important thing for me. And I think it's very obvious to see the quality of a type system if you look into the inference. So I will basically just talk about the inference part here. So reliable type inference will influence the way you write code. And maybe you have been realizing this if you have been working in Java or C#. Let's see a simple example. Just imagine this is a code example inside a function body. It's not a public interface, it's not top-level code, it's inside a function. And we have this intermediate function called inc, like increment. And it gets a number and returns a number. And in TypeScript, you need to annotate the type parameters, the parameter types, because of the way they analyze the code. It is necessary. If you don't do it, it will assume it to be any. And I will get to any a little bit later, why this is bad. But in this example, this will type check, everything will be fine. And now, for Flow, we also have this intermediate function increment, which gets n and returns n plus 1. And now comes the more interesting part of type inference. So I don't have to annotate everything. Like Flow can assume just by seeing the plus sign that this can eventually be a number or a string, because both can be like summed up, kind of. And because of that information, so what usually happens is that Flow itself has a graph-like analysis. So it will, as soon as it encounters a type which is not obvious, it will declare it as an open type. And as soon as it has collected all the information when it parsed the whole AST, it will do another run and then see if, with this context it already gathered, if it can infer the type. So here it can see, okay, it passes 1, 2, 3, we have the plus sign, so this can be clearly type checked. In the contrary of TypeScript, they do an AST, a very simple AST. Well, not very simple, it's obviously a very complicated topic, but they just walk down the AST and assign the types on the go. They don't do this revisiting thing, which is just a design decision of their on their own, because they wanted to deliver, they wanted to cover a different use case. So they wanted also to onboard C# and Java developers, and they wanted to be more class-oriented. And because of variance, classes need to be annotated anyway, so they thought it would be a better idea to provide type annotations for every function. But for me, personally, this was a problem, because I'm using a lot of functional patterns. And if you're used to functional patterns, I will just explain a little example here. So we have a compose function which composes 3 functions together, increment 1, 2, and 3. And out of this compose function, we get a new function, which is increment 6. So when we try to increment 6 a number 2, it would return 8. So these functions need to be declared. Like in the example before, we need to say const increment 1 equals n plus 1. But if I use TypeScript, for instance, I would be required to annotate everything. And this is not something I want. Inside a function, I don't want to be explicit about anything, because you have the public interfaces, and everything inside is just an implementation detail, right? I want to be like just be able to write my code and don't worry about type annotations. But at the same time, I want to be type safe. That's the most important part. The type system should not get into my way. So what happens is I pass in the 2, it goes through the increment 1, so I get 3 out of it. It puts the output into the new function increment 2, and so on, and in the end I get 8. And Flow does a really good job. That's also why it's called Flow, because it really analyzes the code flow, how the code flows through the functions, and can very strongly analyze your code. The same goes for React. And I mean, React and Flow is developed by Facebook or by teams in Facebook. So of course they try to be adapt to the patterns of React. And there is more a trend of going to stateless functions. So what we have is we have a function here which takes a props parameter, which is an object type with a user attribute, which is a string. And then it returns some GSX. So the pure function says, give me some object and return some GSX. And this is really nice for Flow. Reliable type inference will motivate experimentation and changes. And I mean, of course, you can also experiment and do a lot of changes in TypeScript as well. But if you just omit the type parameters in your annotations, it will just use any. So everything which is happening inside is unchecked. But I want to move fast and try things out inside a module as well. So private functions, I don't care about annotations in private functions, because what is important is the public interface, which is getting populated outside. So Flow enforces only type annotations for module.exports. Yeah, so in that case, like in Java, this was always a problem for me, because when you had to, just imagine, you wanted to introduce a new model or something. You had to create a new class, then you needed to add attributes, you needed to tell which type these attributes are, then you needed to define getters and setters. This was a lot of boilerplate for just experimenting. And just think about how many times have you been saying to yourself, well, I could have tried it out, but so much code to write, no, I don't do that. So this is something I wanted to prevent. The type system should not get into the way, especially if you have a compiler in place, because then, yeah, it's not compiling and not running, and it's very tedious. So let's talk about trust killers and this kind of type systems. So first, straight from hell is the anytype. Like, I don't know anything which is worse, especially in Flow, if you want to have local type inference. Then another popular choice is object, which, yeah, is a little bit better than any, but it's still very generic. And you nuke also all the types when you're using function, and function is even worse than object, because it has 2 types to define: the input parameters and the output. So for example, we have our function here, and we just don't care what the input parameters, we declare it as any. And you can pass in whatever you want. It doesn't care. So this is pretty much worthless and even dangerous. Sometimes it's useful. So if you want to, if you have an object which clearly is some specific type, you can typecast it with the parentheses, and you just say :any. So it erases the type information of this specific sum object, and then you can typecast it to whatever you want. But you need to be, if you do this, you need to be very aware what you're doing, because then you're opting out of the type system, so you don't have the runtime guarantees that your code will not break. So go back to our compose function. So we have a function which gets a generic T1 and outputs T2. This is how the type system would see it. And we have our compose chain. So if you put in any, and we have only local type inference, that means if these functions are not annotated at all, it can just return any, because it just says, okay, I get any, and plus whatever is any. It's like the example during Douglas' talk with not a number, for instance. So it's really complicated. How does this compose? Any. So this is bad. We lose our type information without us noticing sometimes. And this really hits you in the trust of the system. You're like, I'm getting a little bit paranoid, and try to type out everything. And then you get back to this very tedious, rigid loop. The same goes for the modules. So if you have modules and you import them, they might sometimes export any or deliver any, and then you have no idea what's breaking. Let's see how we would design an application. So usually what you would try to do if you have a really strong type system is you define your model types. These are virtual, especially in Flow. So the virtual space types and the JavaScript code are separated. So it's not real code. It's not going to be executed. You have your model types, like your user or comment object. You have your business logic, which operates on these information and maybe creates other types as well. And we have our UI components, which are consuming, like the React stateless function we saw before. You get props with certain attributes. They also can use the model types, so you can reuse everything. And inside this application, everything is tightly locked together. So when you try to change some attribute on a model, if you introduce a nullable type, suddenly you will see all the errors popping up in the business logic and in the UI saying, hey, you're trying to access a value which might be null in the future, or which might be null if you pass in some data from whatever. So you need to check it for nullability. Like, you have to check if it's a null value. And I like to imagine it like a little fortress. Like, you have your very tightly coherent application, and since we're here in St. Petersburg, I would say this is the fortress of St. Petersburg. And yeah, it's really nice to just know that if I don't have any or function or object or whatever, or if I manage them correctly, you can be 99% sure that your application will not break during runtime, which is very good. And I told you before I was working on React Native, and this is very crucial for React Native. If you have a null pointer exception in React Native and a UI component cannot render, it will just throw an error and will crash your whole application. This is really bad. You don't want, like in general, you don't want the application to crash completely. You want to be safe on that side. So in that manner, Flow did help a lot preventing our crashes. What we don't usually see is we have our app, and the app is very tightly coupled and everything, but of course we need to communicate with the outside world, otherwise our program would be useless. So we have user interactions, we have server communication, we have libraries like node modules or whatever. And since JavaScript doesn't have a very good standard library, of course, we are required to use a lot of node modules. So maybe let's see how we can prevent errors on the server side. So we have server communication with a REST interface, for instance, very common. It delivers JSON, and what we usually want to do is we need to put a validator in place. A validator which is aware of our model types and which analyzes the incoming data during the runtime. So we can make sure that the data is really matching our type specs. And then, through the validator, we can use the information in our tightly ruled application. And so there are some examples how you can do that, because usually you would be required to duplicate the type information and the schema validation. So this information is not really dry. So there are some solutions like Flow Runtime, which offers you a Babel plugin to transpile your type information into validation routines. And this is very useful. And also the more lightweight version, Andre Pop, did a validated library, which is also very Flow-centric. He's also from St. Petersburg, I think. And yeah, it's also a very nice solution. I mean, this also has a really big downside. If you have a lot of data and you have to verify it, especially on the mobile side, you have a lot of computation cycles, because you check everything and you have maybe deeply nested structures, which has, of course, a runtime impact. But hey, you're typed, I guess, so that's cool. It's yeah, very pure. Another solution would be having something in place like GraphQL. So GraphQL is a protocol and a server implementation for schema-based server communication. So you can have these GraphQL schema, which is, of course, kind of graph-based, and frameworks like Relay can give you tools to generate flow types from this schema. So you can at least automate this process. And then you can just communicate with GraphQL, because the contract ensures that you get the information in the correct format. So you kind of put the validation process on the server side. And a lot of people are arguing, yeah, well, we cannot use GraphQL for that because we already have a REST endpoint. That's no problem. It's also possible to just put an intermediate GraphQL server between your REST interface and your application. But this is like a complete topic on its own, so maybe you want to check it out. It's just an advice how you can get type-safe on that side. Cool. So what about third-party libraries? This is like my biggest pain right now because I've always been contributing to this ecosystem and it's just very hard to do it right. So what we have in Flow is these things called library definitions. And library definitions are kind of the contract how you communicate with your Node module. And they use a very specific syntax. So what you have is declare syntax, which tells Flow how an entity is being built up. So we have, for instance, our favorite library Lodash. Declare module Lodash, which has a declare module.export. So it's a common JS module for Flow, and it exports for you a map function. And I know I told you N is a very bad, but it's very small slide, so I had to do this. Actually, it's a very common use case. If you're gradually introducing Flow into your code base, because you can do this file by file, sometimes you are using a library and you don't really know what the interface is. And what people do is usually they create a scaffold of the project and just type it as any or as function, and as soon as they feel comfortable with Flow, they can gradually introduce more tight typings here. Sometimes it's also not even possible because some libraries are not designed with static types in mind. So the whole point why I'm even talking about Flow like so rigorously is that I want you to know, like, library definition writers and TypeScript definition writers have a much, much easier time to type your libraries if you think about types. If you make too many side-effectual code, it's very hard to type it. And then in the end, you have a very bad user experience. And maybe you noticed this comment on the top. So flow typed npm lodash_v4. This is a convention defined by flow typed. Flow typed is a project for for the release of official library definitions for more common libraries. So you can find a lot of libraries there. I've also contributed a little bit with Redux Saga. So if you're using Redux Saga and you have problems with this library definition, you can come to me as well. So the problem is Flow has been growing a lot. So as I told you, 0.15 to 0.46 is a lot of version releases. And of course, they add new declare syntax or they refine their analysis algorithm. And FlowType makes sure that your Flow version and your library version does fit together. It's a really complicated topic. Also, we needed to write our own Semver matching process. It's like super tedious. This is one of the things I really dislike about Flow, that it's very hard to keep track of these library definitions. And maybe let's see it from a point of the point of view of a maintainer. So you're the maintainer of this library, and you need to create these library definitions. Either you write them by hand, or maybe you find a way to generate them. Even if your library is written with Flow in mind, it's a little bit problematic. You can publish both. You can publish to npm, you can publish to flow typed. You need to make sure these are in sync. And the consumer is then using npm install and flow typed install. Flow typed is also a CLI tool. And a lot of people ask me, well, can't you just distribute your Node module with flow typings and then you consume them? Yes, it's possible. The problem is, most of the time, third-party libraries are also depending on third-party libraries. So you have, like this graph problem of Node modules, which you download the whole internet. So the same applies to Flow, and it's even worse because some libraries are using a different Flow version than you are. And as I said, the analysis procedure changes with the time. And if you're using a more modern version of Flow, you might get Flow errors when you consume this library with Flow typings. This is really bad. But just imagine we have our application, we have our third-party libraries, we have the library definitions, we have the server communication settled. So now this is our fully typed architecture. And about the user interaction, I also find this symbol very fitting because like I built my wonderful application and the user is just like attacking it with whatever they do. The user interaction are quite easily settled because Flow delivers, like for React, Flow delivers internal library definitions. And they are really well typed. So for on-click event handlers, you always get the typed event object. Cool. And theoretically, this is my ideal world. If everything, like the validators and the library definitions, if everything is in place and I don't introduce too many any's, this application is rock solid. So you have, I don't know, really 99% covered during runtime. Also, it's very easy to refactor later on. Because you know exactly when you do a change somewhere, you will automatically see where these changes will break your code. So you don't have to unit test your function calls anymore, like if the right parameter list was provided and stuff like this. Okay, so we started out with Java, which was, the nominalist typed system is not the best for me. So then I was introduced to JavaScript and it was awesome. At some point I was like, ugh, it's so hard to maintain, the side effects are everywhere, I don't know what to do. And with React it was a little bit easier because you suddenly broke up your application in this nice component behavior. Then with Flow it was like amazing. Like the major difference between Flow and Java is day and night. Like the type system is so concise, it gets so out of your way that you really can concentrate on building stuff. Unless you have to introduce very complicated library definitions, then it's getting really tedious. So I'm kind of okay right now. So whenever I write JavaScript, I usually type it. There is a lot of support also for Node. But what can we do better? What can we do better? How can we improve? So my personal decision was that I think JavaScript is too almighty. You can do pretty much everything with it. You can do object orientation, you can imperative programming, procedural programming, functional programming, like everything is in there. So it's so hard to optimize a type system for that. So I think that an alternative language which compiles to JavaScript might be really the true way. So I think TypeScript does a really good job in this position. The biggest problem with TypeScript is that it still tries to be JavaScript some kind of. I want to be more functional. As I said, like the React paradigm kind of shifts to this functional concepts. I want to have automatic immutability if I want it. I wanted to have auto-currying if I want to compose functions. I want to have like first level support for composition. And I want this really, really nice type safetiness where I can say I don't have to annotate anything, but it still knows what I mean. Pretty much like a human being. So a lot of people, yeah, and also strong tooling, of course, that I have reliable auto-completion and all this stuff. So a lot of people will refer me like, oh, Patrick, you could use Elm or PureScript. Yeah, that's cool. I mean, it's really nice. Elm is probably would be my first go-to thing if more people would be into this Haskell-like experience. But, and also PureScript. They're pretty much the best solution I know right there. But I mean, it's always about, familiarity. So if you cannot convince your coworkers that this is a nice solution, then yeah, and also syntax is also a very emotional topic. So a lot of people, for instance, if you talk about Lisp, you have a lot of people who are like, oh, Lisp is so great, it's the best syntax ever, because there is no syntax. It's just parentheses everywhere. And then there's another developer saying, yeah, well, I don't really like the parentheses, and that's why you completely skip a technology. And also the interoperability is a problem. Like in cases of Elm, you need to have these, ports which do some serialization magic, and it's just not straightforward. I just want to go into the JavaScript namespace and just call something, just a log function or something. So these are out of options. So, yeah, that was interesting. So Thank you for coming. No. Okay, so for 2017, what I believe is a very good solution, probably you have read the description of my talk, is ReasonML. And what the heck is ReasonML? So I will explain it. ReasonML is based on OCaml, and OCaml is a very old language. If you know it, it's approximately 20 years old, and it's also based on a Hindley-Miller type system, algorithm kind of thing. I'm not a super type system scientist, I'm very practical, so it's very similar to how Haskell does the type inference. So it's a very solid foundation to build like this whole thing on. And the O also stands for objective. So it is usually a functional programming language, but it has ways to do object-oriented programming. And it also allows you to do imperative code. You can have for loops in there. You can have intermediate state in there. It's just really a very nicely designed practical language. The biggest problem is it's very scientific. Like it's in a very scientific context. So the community is not really a fan of designing things. They're like, if you look into the docs, they're quite plain HTML and sometimes really confusing. And on top of this OCaml, there's the compiler, there is a package manager called OPAM, there is Merlin, which is the utility tool for autocompletion and editor integration. And now on top of that, there is Reason. And a nice thing about OCaml is they always thought it would be a good idea to have compiler hooks to add additional syntax, very similar to how Babel does it with the Babel plugins. So what they do is they introduce a new syntax, which is using the syntax interface of the OCaml build compiler, and introduce a JavaScript-like experience. So what they try to do is they want to emulate ES6 in a more directed way. They want to leave out the bad parts and really concentrate on the functional patterns, so that it's very easy to have very nice immutability, type inference, and all this stuff. They also build tools on that. And I will show you what kind of tools they are. It's like, for instance, pretty printing code by analyzing the EST. And also they want to introduce tools to connect the NPM ecosystem to OCaml. So they want to get rid, like they don't want the JS community to interface with the OCaml environment. So when you think about OPAM, it's a little bit different to NPM. It's a little bit complicated sometimes because it acts differently. And they just want to get away from that, just publish everything on NPM and then use NPM as your package manager. And maybe you see the Reason and the JavaScript community puzzle piece are kind of the same shape. So they made it in a way that it's kind of optional, so you can put it out and just plug the developer to the compiler and the OCaml ecosystem. So if you don't feel comfortable with Reason, you can still use OCaml. And this enables a huge dimension, because suddenly you can have the OCaml community and the JavaScript community have a conversation with each other. The more practical side on the JavaScript and more scientific side on OCaml. On top of that, so we have now the Reason syntax and we have OCaml, but who does the JavaScript magic? This is called BuckleScript. BuckleScript is a platform developed by Bloomberg, and what it tries to do is it packs the OCaml compiler all the stuff you need to build JavaScript files in an NPM package. So you just say npm install globally BS platform and you have everything set. Now you can develop. And this is really nice. It's kind of like TypeScript does it, so you have one package to do it all. And BuckleScript heavily uses Reason as well, so it understands the Reason syntax and the ML, which is OCaml. And it emits, so it reads it, parses it, and then emits JavaScript files. And OCaml, as I said, is also objective, so it has imperative and functional. So it fits really well on the JavaScript syntax. You can replicate probably every scenario, every code pattern you're using in JavaScript. So when you think about tooling, so now we have JavaScript tooling, we have Babel, which is basically compiling your code anyways, so yeah, you are not using pure JavaScript anyways. You have the static types with Flow. With Flow type the library definitions. You have ESLint to check your styles. You have Lodash. You have Lambda. You have immutable.js if you want to be functional. This is a lot of stuff. This all has to work together. It's really Webpack as well, but we still need Webpack though. So in Reason, you can pretty much skip everything. So ESLint will be replaced by reformat, which is very similar to Go format or Prettier, if you know Prettier. Prettier was actually inspired by reformat. And yeah, we can all skip the standard library stuff because BuckleScript transpiles pure OCaml's code, and the OCaml standard library is quite extensive. Okay, so this is everything which is left. Looks pretty neat, right? And I mean, I don't know, I tried to make this as concise as possible so everyone can understand it, but I think it's very hard to imagine how the experience is if you don't really see it live. So bear with me, because I'm also very new to the syntax actually. I've been using it for a few weeks. I've been building some native stuff, so single executables, and also some Reason React stuff, because there are official React bindings to that. I will just explain step by step what is happening. So we have this project tic-tac-toe. And I would just show what this looks like. I mean, it's not very pretty, but hey, we have bumps. So here we are. We can just like click on that, and yeah, it's very simple demo. And yeah, this is the application. And I just want to show you what is required to make this happen. So we have our package JSON. We have the BS platform, as I told you. We installed this version here. We have Webpack for asset management, and actually the other stuff is not really necessary. We just need React DOM and React. And so what we also have is a BuckleScript configuration, which is very similar to Babel configuration. So we just say we enable GSX syntax. There is also first level support for GSX. We add our library definitions. Buckle types is also a very nice way to express your type definitions. So we have bindings to React, and yeah, and the additional libraries here. And then we give it a source, and then we just say, okay, please just watch all the content which is in there in my source directory. And all the Reason and ML files will be parsed and then transpiled into JavaScript. So let's go back to the package JSON. We have scripts, and here is the magic. So we start BuckleScript, and this will just initiate the BuckleScript builder. And it's also automatically in watch mode with the -W. And after that, we will launch Webpack to create a single bundle. So okay, so first of all, we have a signature mismatch, and this is because I'm in the wrong project. Okay. All right, no. Okay, I wanted to show you two examples actually. So this here is just a very basic, of course, a very basic counter example where you can count up and down. Just wanted to show you how this looks like. So it's a very similar setup, just a little bit more simpler. And we have one counter.re in there, and we also have an index file in there. And this is also very interesting, because what we do is we use Webpack to bundle this thing, and then we just include it in a script tag. It's nothing fancy. It's very, very basic, and I love it, because if you think about it, how many tools we stack on each other, it's getting so overwhelming, and it's very hard to debug. This takes the focus away from the tooling and more into the code. All right, so now we run Webpack here. We go into a Reason demo, and let's see, we had counter.re. Okay. So we try to implement something in React here. And if you're familiar with React, it looks a little bit different, but this is a subject to change. So we usually have our React DOM re, which renders our element in our DOM. We have our modules, we have a module counter, which will be our stateful component. So we include the interface for stateful. And then it requires us, it will tell us, first of all, it's statically typed. So on the bottom, you can see signature mismatch, that we need a state. Of course, we need to type a state. So we say state equals count integer. And we also have a distinction between integer and float and all this stuff. So this is nice. At least better. I don't know. I like it to have it more granular at some point. We have get initial state. So hopefully, please deal with me if I'm doing syntax errors, because sometimes it's really overly exciting. So what we now have is a render function, and this render function gets an object, and then we can get the state and a so-called updater function, which is a declarative way to register events and event handlers. So we would increment something with a function, so we get a state and return. So this is the way how you define a function with an arrow. And then it requires us to return an optional value. So it can be either nothing, which would be none, or we return some. The last statement is also automatically the return value. So let's see if this worked. Okay, this works. And if it doesn't compile, it will not run. So this is also a nice thing. Then we have a decrement. And return count, state.count, or actually -1. Let's do it like this. This looks weird. Okay. OCaml automatically tells you if you have unused variables, so you don't have to worry about ESLint stuff. And now we will register the button. So the syntax looks a little bit different here. So what we do is we register updater, which is a function which takes a function and returns you a new function. Just put in the increment function in there. Then, since it's a very statically typed language, we need to create an element here, which is plus. So hopefully this compiles. All right, this compiles actually. That's cool. So then we have an updater decrement, which has minus. Does this work? So what am I doing wrong here? Get initial state. Maybe I typed it wrongly. Get initial state. That's weird. Better. Yeah, so get initial state is usually a function. And we can also see it, I have a lookup function where you can see on the bottom, it takes a generic A and returns a new state. Okay, and if you want to introduce, actually, how much time do we have left? So we don't have any, oh yeah, right, 15 minutes, oh, that's enough time. All right, so now we have our state right here, right? So we want to render also the value which we have been using. which we want to increment. So what we do here is we basically just say state.count. But we need to, so we need to say string to element, and then we say string of int. That should be it. Yeah. And if we do this, it kind of works. So what a lot of people have, a lot of problems is that if you do this GSX stuff, this is why people hate GSX, is that it's very tedious to format, right? You need to shift it around and your editor doesn't support it. And now comes the magic part with reformat. I told you about that. If I have a hook here, it's a hotkey, reformat, and bam, that's it. So just so you see the difference right here, it just reformats it. And it does really crazy stuff with that. So if I define, so maybe let's see another example. Back to the tic-tac-toe. So we have a game file, we have a game module. And I wanted to show you a little bit the type syntax. So we can define types and we can use types in our code. This is not something you can do in Flow. And you can really express a whole application just with algebraic types. So for instance, and the nice thing about it is that we don't actually have to annotate anything. It kind of automatically knows what value is what. So for instance, oops. Maybe let's make a little state machine. Let's see if I can do this. So we have, like Redux, for instance. If you have your Redux, you usually have a Redux state. And we have a user which will require, for instance, we want to request a user object. And a user request, what is a user request? It can either be none, I call it nope. It can be pending with a certain ID, for instance, or it can be successful with a user object. And the type user is just a name. And in the state, we can just use our user request in here. So we can reformat it. Whoop, that's fast. All right. So then we can go ahead and just make, I don't know, let's call it main. I don't know. And I would like to have a reducer. Like we have it in Redux. So we usually get a state, we get an action, and then we do something with it. And usually what we have in there is a switch. And then we can switch on the action. And now comes the most important part in any functional language, is pattern matching. So you can do, I can pattern match on, oh actually we need an action, right? So we have type action, which can be query user, which gets an ID. Whoa, what's happening? We can have query success, which has the user object in there. So if we try to match on that query user, we automatically know that we have an ID. And then return a new state, which would be, what do we have here? Where's our state? Ah, user, yeah, true. Actually, user would be nope. Actually pending, right? So it would be pending with an ID. And then we would have query success, which would be the user object, and then we just say user is user. Or actually success user. Maybe reformat it. Oh, wonderful. I love it. Like the reformatting is, if you didn't check out Prettier, you should really check out Prettier because it's so amazing. It gets away everything, like gets everything out of the way. Okay, so now we have a reducer. And we would probably try to use our reducer in our application somehow. So let's say we have a new state and we say we give the reducer another state which is user nope. So there is no user existent. And then we give it an action. We say query, oh actually we need to wrap it in parentheses. So we say query user with ID U1. And now we have a new state which is SM state. And maybe you noticed that I never really used any type annotations. Why? Because of the way the type system is inferring the types. Just the fact that I use a switch with these tags, with these type tags, they are not really, they're just like enums. It knows automatically that action has to be an action object. Maybe I call it action T, then it's easier to see. So now it's an action T, you can see it on the bottom. So it automatically just analyzes the flow. It's actually a very similar algorithm like Flow implements it, but it's much stronger because it has the language support for it. All right. And if we want to access a new state stuff, for instance, we want to know the user now. Maybe it's a user. We could pattern match on new state dot user, hopefully. And if it's pending, we get an ID, and then we can render, like in the UI, we can then say, okay, this is currently pending, and I can show a spinner. I don't have to use maybe types, I don't have to use null checks, like all this weird stuff which is not really expressing your application. So these are the things, like this is a sound program. If it compiles, you can be sure that this will run, and this will dictate the way you code. Because usually what we do is, we code something, we go to the browser, we check it, oh, it's working, okay, cool. And then you do it again. Here you're basically just concentrating on the code, you're just concentrating on the compiler to compile, and you can be sure that the business logic, like the code is running, and you just need to fix the business logic. All right. So just for recapitulation, first of all, we should use a type system which is really intelligent in its type inference. Second of all, we need to build an application which is like a little fortress. We need to have the right library definitions, which in Reason are much more concise and much more integrated in the language itself. And we need to have a way to do proper validation which doesn't have a huge runtime impact. Okay, cool. That was it. Thanks, and I'm open up for questions.
У кого есть вопросы, поднимайте руку.
Hi, thank you for your talk, and these slides are brilliant. The pictures are great. So about the ReasonML, so do you think that it is production ready? So do you use it in production, or it's just experimenting?
So I believe that this thing is production ready, because also if you go into the community and ask the question, Cheng Lu is also in the Messenger team, like Facebook Messenger, and 20% of the Facebook Messenger is currently running on Reason. It's very easy to integrate it in your existing pipeline, so you can use it with Webpack with a specific BackScript loader. And the only thing what I really urge like people to try it, the problem is that it has a, I mean, if you don't know these things, like how this whole thing is architectured, you have a very hard time getting into it. But as soon as you get the first step and you suddenly understand the concepts behind it, your performance will peak exponentially. I believe it really has a huge potential. if you want to do functional programming and statically typed programming, all in all. For me, it's the best alternative right now. And I also built something with it right now. So.
Yeah. Thank you. Yeah.
Okay.
Еще вопросы?
There's a question over there.
Hi, Patrick. Thanks for your talk. By the way, we sent your hi to Andrei Pope during your talk. The question is it possible to gradually go from JS and, for example, Flow covered JavaScript and in same way gradually file by file integrate Reason and have at some point transition type of project, like half of the code base in Reason, half of the code base in JavaScript. And maybe second question, are there any tools to automatically like code mods?
First of all, yeah, the first question, yes, it's possible to gradually introduce Reason. As I said, there is a Webpack loader called bs-loader. So you can basically transpile component-wise, so you can have several components if you're using React. The only downside is that BuckleScript has to introduce a little bit of runtime code because it has autocurring and all this stuff. So there is some code there which you usually don't have, but this is something which will optimize later if your complete code base in Reason. Second question, there are tools for kind of code modding things. One is called JSON, so J-E-A-S-O-N, and it's kind of a hacky solution. So what they do is they use the Flow parser, which is written in OCaml, and build the AST from it, and then transform it to Reason code. And if you use JSON, you get like 70% of your JavaScript code into Reason, and the rest you need to type yourself. But it's something you just follow the compiler errors, and then it should work. That's another question.
Hi. Patrick, a little question. I see you are using Emacs. Are there many editors supporting now BuckleScript and Reason?
Yes. I mean, there is, of course, for the more esoterical ones, Vim, Emacs, etc., there is a plugin. And also for Visual Studio Code is a really, really good plugin. So if I would be using a more graphical editor, I would be using VS Code for that. Atom also has an integration with Nuclide, but not a lot of people like Nuclide. Yeah, but there is major support for that.
Thank you.
Hello, Patrick. Thank you for your talk. We all not only write code, but read code like a lot. What do you think is better for readability-wise, explicit type definitions or implicit type definitions?
Both. So, as I said, you should usually, I heavily rely on inference inside private scope. Most of the time, if you're doing functional programming, your variable name should tell you what this thing does. It's automatically like the documentation kind of thing. So the intermediate functions are kind of self-explanatory. But for public interfaces, module exports, and component documentation, you should do explicit typing. And Reason has support for that with so-called interface files, which sits beside your implementation. It's very similar to header files in C. And you can really lock down the implementation as soon as you're happy with it. So this is also very nice. Also, OCaml can generate, OCaml can take your implementation and generate the interface for you. So you don't have to write it twice.
Есть время еще на последний вопрос. Поднимите руку.
Hi, Patrick. Thank you for your talk. You show us the great example of functional typing, and the question is, are types work still still so good for object-oriented code? So does this ReasonML will still work well for like JavaScript inheritance, prototyping, and so on? So
BuckleScript has its own interfaces for JavaScript. So it has possibilities to do all kinds of paradigms in JavaScript. You can even define an interface for reason. So you have a function call, and then you can translate it to a literal blob of JavaScript. You can say it's raw JavaScript, you just put the blob in there if you're really desperate. I mean, most of the cases you don't need it, but you can express all the object-oriented things. You can have your own API kind of, you can map it as you want it. But the fact is just to have a boundary, which is the reason library definition. If this is well typed, everything in your application is well typed.
But are there any problems like overriding methods when we have like extending or narrowing the scope of child classes? Does it just work well in ReasonML?
So if the prototyper inheritance works well, I mean, I don't use...
Not just prototype, but typed prototyping. So will types will work well for prototyping, overriding methods, and so on?
I never used object-oriented types in OCaml, but what I heard is that the soundness of the protocol-based typing is really strong, really good. But I've never used classes for a very long time, only in stateful components so far.
Mm-hmm. Yes, I got it.
I don't really, I don't use them.
Mm-hmm. Thank you.